Hey everybody, the purpose of this quiz is to get us some solutions to the hypothesis test on soda volumes. We've got a 12-ounce can. We're going to fill on average to 12.1, and we're going to see if our machine is actually doing that correctly. So we take a nice precise meter, measure 35 soda cans volumes. Here's the results we get. I went ahead and threw them in a frequency distribution over here, L1 and L2. Just easier than typing them over and over again, especially on the computer where I can't use the number keypad all the time. And I want to run a template through this to see if this is actually showing a filling of less than, let me make that down, there we go, less than 12.1 ounces. So we are definitely testing an average. Most definitely testing an average. The variable we're testing is the average amount of soda in the can. Okay, definitely. As far as the variables go, our variables are going to be, we're doing mu, right? We want to see if mu is coming in, where's mu? There you are. Is mu coming in at less than or equal, just less than actually. Less than, I can type less than 12.1. Oops, why didn't I get the less than symbol? There we go. That's the claim I want to test. Are we coming in at less than 12.1 ounces? If we are, we got to recalibrate. The converse of that, or the complement of that, let's insert some symbols here. I'm just gonna put equals if that's okay with you guys. I mean, there's three choices. It can be equals 12.1, greater than or equal to 12.1, or not less than. So let's see it. Okay, so type 1 error is going to be saying the amounts are less than 12.1 when they aren't. Less than 1 ounces. I guess the volumes. Volume, amount, it's all the same. Okay, there's your type 1, false positive. Your false negative is going to be saying the amounts are not less than 12.1 when they are. So there's a false negative. Which one's worse in your opinion and why? Your call on that one. I would imagine that the false negative will be worse because then you're potentially flooding the industry with underfilled soda cans, and in a country like America, very litigious, that might cause a lawsuit or two. So if you might want to avoid a type 2 error, I would say lower confidence overall. That'll also lower beta, which is your type 2 error, raise the power of the test. But that's my opinion, just my opinion. Which distribution is most definitely a T distribution? Most definitely. Test statistic and p-value, let's get at that. We have data. We're testing against 12.1. The list is in L1. The frequencies are in L2, and we are seeing if we've got a less than. Let's draw that and take a look at it. Whoa! Wow. Okay, so this is very telling. This is exceptionally telling. So the test statistic is about 1.4. Notice it's positive. That's very interesting to me. It's positive 1.4. That's kind of cool. Since it's positive 1.4, that means we were looking for a negative one, less than 12.1. It came up positive 1.4. That means the average was actually greater. I want to come back to that because that was not what I was expecting looking at those numbers up there. They were on the original quiz. The p-value ends up being pretty huge. 92% just about. Not 0.92, 92%. 0.92 would be actually pretty small. All right, so it does not appear that the cans have less than 12.1 ounces on average. Okay, and let's just finish this one up real quick. That looks like a potential type 2 error. So there's the one I mentioned would have been the worst. That's my opinion, of course. But it doesn't look like it, not based on this. But as I was looking at the original data, this is kind of cool. Quite a few of the data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 of the 35. So what is that? That's 60% of the data points are either 12.1 or less. Now that's interesting to me. I want to look at something real quick. I want to take a look at my data. It looks like it's going to be highly skewed. Yeah, wicked skewed. And you know what we're going to do? We're going to slap a box plot on there too. Slap a box plot on there with it. Oop, I forgot to turn it on, didn't I? I did. Don't mind this equation. I was doing another quiz earlier. All right, it's saying there's no outliers. It's its claim. Let me change the window a little smidge. Make the X scale 0.1. Make this go up to 12.8. Oops, 12.8. Okay, it's saying there's no outliers. It's saying that we've got a nice long tail, but that 12.7 is within the realm of reason. I don't know. I would want more data on this one. I mean, I don't even think it looks like it's bell-shaped data, although I'm not that concerned with bell-shaped. I'm more concerned with the outlier. That 12.7 kind of jumped out at me as I was looking at the 12 zeros. Okay, so the test says they're not under. They look like they're almost overfilling from 12.1. Overfilling would be if you were running your hypothesis test, your p-value would be 8%. Would be overfilled. But regardless of what it is, it looks like they're not being underfilled. So they do not appear to have less than 12 ounces on average. Cool. That was a fun data set. See you guys in class.